Hello Legacy Sabers, Marsh here. So today we're going to look at piecewise functions the first day. We're going to look at how to evaluate them and then also how to write a piecewise function. You're going to want to have your notes, definitely have your notes today because you're going to be doing a lot of writing. You're going to want a calculator for the first like 3 or 4 minutes or so, and then you're going to definitely want a pencil or a writing instrument to take notes. Your learning targets. What do you want to be able to accomplish by the end of this video? You want to be able to evaluate for a specific x value when you're given a piecewise function in a graph or when you're given the actual equations. And you're going to want to be able to do it if you're given a graph when you can write equations of the piecewise function. Doesn't seem like a whole lot, but it does take a little bit, especially to write the equations. So let's get started. So, what is a piecewise function? We kind of looked at these already. Basically, a piecewise function is made up of pieces of different functions which are a result of their different domains. So, in real life, this is basically what a piecewise function is. At a job, you make $8.50 per hour up to 40 hours, but after 40 hours, you make time and a half. So, at 40 hours, we switch the way we calculate your pay to a new function. So basically this would look like this. So from y equals 8.50x for hours 40 or less, but when we go over 40 we would use 12.75 times x. So that's time and a half. So piecewise functions allows us to break a domain up into pieces into different functions. So basically they're not all just straight lines. They're going to look like two straight lines that come together that actually are put together. So, math notation for this would look something like this. So y equals 8.50x, which is x is less than or equal to 40 because we said 40 hours or less, and 1275 x is greater than 40. Now, what are we going to work on today? So I have this function here, and I need to figure out which pieces are going to allow me to evaluate these specific parts of my domain. So we have -2. Where does -2 fall in our if statements? So it falls in this one, right? Because -2 is less than 4. So it looks like I need to plug into that function. So 2 times -2 squared plus 1. So that's 2 times a positive 4 plus 1, which is 2 times 4 is 8 plus 1. That's 9. So my answer's got to be 9. What about 8? 8 is not less than 4, so it doesn't go in there. 8's not between 4 and 7, but 8 is greater than 7. And my function's just 3. My answer must be 3. Just because I don't have an x, can't plug in the 8, so my answer's just 3. What about 4? Well, this is only when it's less than 4, so I can't use that. But this looks like it's when it's equal to 4. So it looks like we're going to plug into this. So 4 times 4 plus 2/3, and I'm going to be lazy. I'm going to leave that as 16 and 2/3. Now, what about if I give you a graph? This is not as hard as you think it is. So they want us to know what is the y value when my x is -6. So on our graph, we're going to find -6 on our x-axis, and then we're going to go up until we hit the function. Boom, right there, right? What y value is that? So I'm going to go over here with find my y value. Boom. Looks like it's 5. So I know my answer for -6 is equal to 5. Let's check 1 out. So I'm going to find 1 on my axes. So right here, we're going to go up until we hit our function. Boom. Now let's go over to the y-axis to see what our answer is. 3. So my answer must be 3. Let's try -1. So here's -1 on my x. Let's go down until we hit something. Oh, there's something. Now notice I went down because there's nothing upstairs, so I got to go downwards. And if I go across, that is the x value of or the y value, excuse me, of -7. I think graphs are even easier than when I'm given the actual equations, because it's a lot easier just to kind of picture the lines in your mind. So, what we're going to do, we're just going to jump straight into writing equations. Here's the reason for this. There are so many different possibilities that can happen in these graphs. It's easier for you guys just to see how does it happen. So here I have this graph, and you see I have two different lines. Here is how I start all of my answers. I am first going to write f of x equals big squiggly curly brace, right there. Now, you're going to do your if parts first. So let's go if, and it looks like we're going to have two ifs, right? Because we have two different lines. Now, let's write this first line here. So, we've written lines before, equations of lines. And I can write, so I got my y-intercept at +3, right? Oh, hold on. No, let's do our ifs first. So, it looks like that from -infinity, so we're using our x values, right? From -infinity to 2, my line is covering, right? -infinity to 2. So it looks like x can be less than or equal to, because that was a closed dot, wasn't it? Let me double check. Is that a closed dot? Yeah, it was. So x can be less than or equal to 2, and then it looks like here I got an open dot, so x can only be greater than 2 right there. Now, let's start writing equations of the lines. So this one, we already said our y-intercept is 3, so I know I'm going to have a +3 on the back half. And what kind of slope I have? It looks like I have down 1 over 1, so that would be -1x plus 3 for my particular part of that graph. Let's see here. Ooh, it doesn't go through. Let's see, if I were to kind of extend this, so it looks like my slope is a -2, right? Because down 2 over 1. So I know I'm going -2x. Let's see here. I'm going to go up 2 over 1. That'll be my new part. Up 2 over 1 right there. So it looks like it's +3 as well. Whoops. Now, some graphs, it's going to be a lot more difficult to find the y-intercept. So what we can do is use our transformations that we learned with our absolute value functions to make writing equations of lines a lot easier. And I'll show you an example here. Here's some useful tools to use when working with Piecewise. Writing domain for pieces of graphs. You need to know how to figure out your x and your y, or your x's. Where do certain pieces of the function cut through your domain. Then your equations of your vertical lines and your horizontal lines. Remember, Hoy, Vux, in case you need to remember them so you don't get lost, that's Hoivux. Okay? General forms are translated. So M, remember, is always your slope. H is the horizontal shift, kind of like we always think about it. And K is your vertical shift. So how did it go up and down? And I'll show you what that means. Absolute value is how we've been looking at it. Your A is the change in the amplitude or the slope of your lines. H, of course, is the horizontal, and K is your vertical. So let's take a look again. So I have this particular equation here. Let's do my very first thing. So I'm going to go f of x equals big squiggly. It looks like we have 3 if parts, right? Because we got 3 different functions going on. Now, let's break up our domain. So I have one that goes right here and stops. So it looks like we're starting at -infinity to -1. So x has to be less than -1. Now notice it's not equal because I have an open dot. Now let's figure out this one. Well, it looks like we're going between 2 different pieces. So it's going to have x in the middle of these two. And there looks like we have 2 signs that are equal to. And I need to be less than on this side, but x has to be greater than that side, right? So we're at -1 here. And we're at 1, 2, 3 on my x over there. And then it looks like x needs to be greater than 3 right here, right? Because this is where I'm hitting at greater than 3. Now, let's write these equations. Let's use the translated form. So, very first thing we're going to need, what is our slope? Well, I'm going to go down 1 over 2. So, down 1 over 2 is negative 1/2, right? Now, put parentheses. How did I move left or right? Well, I moved left 1, right, to get to here from the y-axis. So left 1, remember in our transformations, we go opposite of what we thought. So instead of going -1, we're going to go +1. And then it looks like we went down 1. So I get to put it like that. Now, you do not need to distribute that in. You don't need to distribute the 1/2 in. You don't need to do anything of that nature. You can just leave it like that. That is the wonderful part about it. You don't need to distribute. And imagine trying to find what the y-intercept would have been of that. It would have been a little harder to find out. So that is a lot easier for us to write in that form. What about this one that's the sandwich here? Well, it's a horizontal line. So horizontal is y equals, and it looks like it's just at a number, which is 2. Pretty easy, right? When they're a constant or they're a horizontal line, those are really easy when you get to those. Let's try to find this one. So, looks like we got to use our newfound skill of translated linear equations. What's my slope? I'm going down 1 over 1. So it looks like I'm going to -1. X. Now, how did I move? I moved 1, 2, 3 to the right. So opposite of that, we're going to think we're going to move -3. And then I moved 1, 2, 3, 4 up. Not too bad, right? Same transformations that we've been using with our absolute values. Now, looks like we have 3 pieces on here. You can see this as 4, but I recommend seeing this as 3 pieces. So we got this v here, absolute value function. We have a constant function, and then we have a linear function. So we got to write our f of x equals big curly brace, and it looks like we need 3 ifs again. There we go. So we start at -infinity, and we go until not here, but it looks like we go 1 more. So that's at -2. So it looks like x needs to be less than... Ooh, I don't have dots. When you don't have dots, what you need to do is make sure that one side is less than and one side is equal to. So when there's 2 equations meeting at one spot, one of them needs to be a less than and one of them needs to be equal to. Here's the reason. You can't have them both equal to, otherwise you don't know what to plug into when you would do evaluations. So I always recommend do the left side function so that it is equal to. So I'm going to do an equal to -2 here. But what that means is down here at our next one, when I put the -2, I need to not be equal to. I can only just be like that. So x needs to be greater than -2, but he can't be more than 3. So x has to be less than, and I'm going to put an equal to 3, because I'm going to make it on the left side. The left side function gets it. So then x needs to be only greater than 3 right here. These cannot be the same symbol unless there'd be a big open dot there. Otherwise, I wouldn't know where to plug in, and I would have 2 different answers for x equals 3. So that's why we need to kind of be careful about that. So now, let's write our equations. So it looks like I got a v here. So my slope of my lines, or the slope of my arms, is up 2 over 1, and it's a right side up v, right? So it's just going to be a +2. X, looks like we moved to the left 3, so I'm going to go, +3. And looks like we moved up 2, so +2. Okay, and then it looks like we got a constant function between -2 and 3. 1, 2, 3, sitting at just 4. And then what kind of line do we got here? Let's find our slope first. Down 1, 2, 3 over 1, so -3 is our slope. X, and then the x value here, 1, 2, 3, so we're going to go -3. 1, 2, 3, 4, +4. Whoops. And that's the end of this video. See you later, Sabers.